Hey everybody, it's hwsteele. Today is August 18th, 2021, which makes this the third weekly video for the month of August 2021. Being the third weekly video, that means we're pretty much right in the middle of August, which means we're pretty much right in the middle of summer, so we are in the dog days of summer. Now in this video, I want to talk to you about some shapes. We're talking kindergarten level education here. So I'm going to bring up the paint program here from Windows, and we're going to draw some shapes and talk about them just a little bit here. First, I'm going to talk about and draw a square. Square, we all know a square, right? It's a two-dimensional shape. It has four sides, equal lengths, and it has 360, let me write this down, internal degrees. And what that means is if we measure the angle between the corners, obviously the square has four corners, there are 90 degrees between these right here, and if you add up the four corners of 90 degrees, you get a total of 360. So there are 360 degrees in angles inside of the square, and of course the square is an enclosed shape. Now if we go to a triangle here, let me draw one of these. Triangle, of course, has three sides, and it is a two-dimensional shape, obviously, and it's an enclosed shape, and it has a total of 180 internal degrees. So let me write that down right there. Now you'll notice that the square has one more side than the triangle. Triangle has three, square has four. The triangle has 180 internal degrees, and the square has 360 internal degrees, which is 180 more than the triangle. So if I draw a pentagon right down here, we see that the pentagon obviously has five corners, and the angle between these corners, this is 60 degrees, this is 90 degrees, this is 108 degrees for a total of, let's bring the calculator up here, make this a lot easier, 108 degrees times five corners equals 540 total internal degrees. So let's go ahead and write this down real quickly. 540 internal degrees right there. Now you'll notice that 540 is 180 degrees more than 360. So we're noticing a pattern here. We'll go up one more shape. This shape is the hexagon. It has six sides of equal length, which makes it have six corners, and it has a total of 720 internal degrees. Right there, 720 degrees. So you'll notice the pattern is every time we add one more side to our shape, our two-dimensional shape that is enclosed, meaning all of the corners touch each other. So there's a line that goes all the way around the perimeter of the shape, creating the shape. Every time we add a new side to it, we have to add 180 internal degrees. So that's something to keep in mind. Now, something that's really interesting is once we get past four sides here, we can actually start drawing on the shapes, or I should say in the shapes, and it starts to look like, it starts to mimic the way three-dimensional shapes look. For instance, if I draw a line in this pentagon right like this pentagon kind of looks like a wedge now, a three-dimensional wedge, right? And if I draw three lines on this hexagon, all of a sudden it starts to look like a three-dimensional cube, right? A cube or a three-dimensional square. Now what's interesting here is we have a shape that has an odd number of sides, and when we draw our line in here to give it the three-dimensional illusion, we have an irregular space, meaning this space right up here is not the same size as this space down here. But this even number of sided shape, this hexagon right here, has six sides, obviously an even number. Basically drawing these three lines here makes it look like a three-dimensional cube. It's an optical illusion, obviously, but each one of these shapes is uniform. It's the same size. And it actually has 3 sections. 1, 2, 3, where there's 2 right here that are not the same size. This one has 3 sections that are the same size. Okay, so now I'm going to remove all this stuff, and I'm going to draw a larger square right here, right in the middle. Now inside this square, I'm going to take a angle or a triangle tool here and draw the triangle inside that square like this, right? So we have an equilateral triangle, 60 degrees on each one right here, each corner. And I just put it so that the base of the triangle is the same size as the square, which makes the height of the triangle the same size as the height of the square. So I'm going to draw another one inside this square, but this triangle I'm going to rotate 180 degrees so that it points down. Now it kind of looks like a backgammon board a little bit, right? So I'm going to draw a third triangle in here, and this one I'm going to rotate to the right 90 degrees. And then I'm going to draw a fourth and final triangle. And I'm going to rotate this one to the left 90 degrees. Now all of a sudden, we see something that looks pretty familiar to us. If I draw a line from this corner to this corner to create a 45-degree angle going up and then a 45-degree angle going down, we have something that looks very familiar to people who study Gann and have observed his overlays. And we have here these angles. That's the 1 by 1 angle, the 1 by 2, 2 by 1, and coming from every corner. And literally all we did was draw 4 triangles, equilateral triangles, the same size as the square, coming from or based on each one of the sides of a square, and then drew an X inside of that, and that gives us this pattern. And of course we have the internal square right there. Then if I take a line segment and draw it from, we'll say right here to the corner right here, and then drag it right there, and right there, we can verify just from moving that one segment that 3 of them fit right there. So this angle crossing right here is the 1/3 distance from the side of the square, right? So you can do measurements like that and try and determine where these lines cross in relationship to the whole of the square. So anyway, I just wanted to show you that, and it's something that you might want to play around with and start measuring the segments here. For instance, like I just showed, the 1/3, the 1/5 shows up. Just see what you can find with it. You never know what you might just learn by looking at things in the most basic and plain way that you possibly can. Or in other words, keeping things as simple as possible.